Okay, so we're gonna give a nice proof of this 3D converse of Desargues theorem. Yeah. Um, and it goes something like this. So you have two triangles, ABC and DEF, perspective about a line. Okay, so that means if you extend the sides, they intersect at points X, Y, and Z, and X, Y, and Z is collinear. Okay. Um, okay, and we prove that if the triangles themselves aren't coplanar, then their perspective from a point, and what that means is that the corresponding vertices of the triangle, um, that if you join them up, those lines are concurrent. Okay, so first we let two of the lines intersect at P. Okay, and we know that the lines intersect at P. Potentially at the point of infinity, but the point is the two lines are coplanar, so they have a two-dimensional intersection. So we have, because AC intersects at Y with DF, those 4 points are coplanar, so P exists on the same plane. And then we want to show that P also lies on BE, and that will finish the proof. Okay. Um, so what we do is we take the intersection of the planes BCEF, so in the light blue points, with the plane ABDE, which are the yellow points. Okay. And we know that the intersection of two planes um, is a line if they're not the same plane, right? So in this case, the line has to be BE because B and E are both points of intersections. And they're not the same plane because the original two triangles are not on the same plane. Okay. Okay, so all we have to do is show that P is in this intersection, okay? But P is in CF. P is defined as the intersection of CF and AD, okay? But CF is in this plane, right? And AD is in that plane. So P is in both planes. So P must be in the intersection, so P must be in B. Okay? And so that proves that the triangle is a perspective from a point. Yeah, so I think with 3D Desargues theorem, like the full 3D statement, like in two dimensions, if you prove like Desargues theorem in one direction, you can just use duality and say the converse is true, right? But in three dimensions, I don't think it's quite so easy because like duality in three dimensions is not the same as lines, and the points and lines aren't dual in three dimensions. They're only dual in two dimensions. Okay. So you have to think of that a bit more than just saying duality, so the converse is true. All right. Any questions?